Good morning to all of you. If I tell you ScanPy, ANDATA, Vitesse, or ZARS, just to name a few, some of you might know what these are. And in fact, these are Python packages that are integrated into a single cell universe. And for a short you can say scverse. Okay, scverse is the winner of the award. But we have a representative here, Ilan Gold, and he's one of the main developer of these software packages. He's a research engineer in Professor Fabian They's group at Helmholtz Munich, and he began by earning a bachelor degree in mathematics at the University of Pennsylvania. And then he moved to Germany, to the Technical University of Munich, where he earned a master's degree in mathematics. He enjoyed so much Germany that he decided to stay there with Professor Theiss. But he's also multi-talented, and he is also a professional musician playing contrabass. So it's with a great pleasure that we present him and the scverse consortium with the Innovative Resource Award.
I just also want to say we have other scverse, at least one other scverse member in the audience here, Gregor, right there. So I'm not the only representative here. Yes, thank you to the SIB for giving us the Innovative Resource Award. Obviously, I'm Ilan Gold, and I want to talk to you a bit about scverse, our story, and how we came to be. So I want to start with a simple question: what is a resource? I started by looking in the dictionary, and I found that the first definition was a little outdated. I don't think that this is what the SIB meant, so that's not it. The second definition was a bit more in bounds: a means of supplying a deficiency or need, something that is a source of help, information, strength, etc. So I want to focus on that and look at the first part, deficiency or need, and see what was the deficiency or need that scverse came to meet. As many of you know, in single cell biology, we often start with a population of cells, perhaps some features we want to focus on, and then we make some measurements, some of which are zero, null, bigger than others, smaller than others. Once those measurements are made, perhaps then you want to analyze your data in Python. Perhaps you like the tooling, perhaps you like the language, whatever the reason may be, you want to use Python, and of course you want to use the normal tools that you have in Python. So perhaps you want to use pandas to analyze metadata or manage labels for cells and genes, store summarized statistics. Perhaps you want to use SciPy for its sparse matrices or for its estimators and sklearn, or perhaps just good old NumPy for dense matrices and linear algebra. The question became clear in the early days of single cell analysis in Python: how do you bring these all under one umbrella data structure? And of course, that's where ANDATA came in. We weren't the first ones or the only ones to come up with this, much like it's our constituents in a bioconductor single cell experiment, Seurat. It has two axes, obs and var, observation and variable, which annotate the main data metrics, x, which could be your RNA counts, your protein expression, what have you. And these annotation axes can store metadata. We also, of course, have multidimensional annotations, self-similarity annotations, but for simplicity, I'm just showing the two main axes here. But you can store their embeddings, graphs, and so forth. And so this became our main entry point for analysis in Python of single-cell data. But we'd be nothing if you couldn't store the data and disseminate it. And to that end, there was always an early focus on using widely used file formats that had strong bases in Python, but also other languages that allowed for reproducibility and dissemination of files. This was very important to the early scverse developers. before even SCverse was a thing, the AND data developers actually. And so we see these as a bit of a backbone to our work. So with the data structure in hand, packages began to emerge. Of course, there was first ScanPy. Many of you know it for RNA-seq, but of course it's as many of you know, agnostic. All it needs is an AND data object. And so this was sort of the first step, but then many other packages emerged. We had SquidPy for spatial analysis. MuData became a secondary data structure for storing multimodal data, so ATAC or CiteSeq for perhaps. scverse from Gregor again, TCR and BCR data analysis from RNA-seq data, and of course SCVI tools serves as a foundational package for sort of traditional variational inference from using deep learning models. But initially, these packages were disparate efforts that sort of had come together around AND data in Python. So the logical next step was to bring everyone under the same roof. And that's what SCverse initially was. It was just sort of a coming together place for these package developers to coordinate efforts and present a unified front to the community. So the initial thought was just to bring together these main developers. A lot of them have either moved on, some of them are still with us, but this was our first foray into building a resource for everyone. So we've just tackled the first half of our definition, what was the deficiency or need, and that's great. But now we want to look at how did SCverse become a source of help, strength, or information for the larger single-cell Python community, and as we'll see, beyond Python. So a little organizational structure of how things are structured at SCverse. We have our core team. These are our day-to-day people, so PhD students, postdocs, engineers like myself. We do development. We do host the community meetings, manage social media, plan events, and so forth. Sort of the day-to-day, the plumbing of what goes on at SCverse. But then, of course, we have like people like Fabian Theis, to me, my PI, the management committee. They help with grant writing. They help with setting up office space, signing on to projects, technical guidance, some funding maybe. And they're a bit more of the day-to-day from the management perspective. But then we have our advisory committee as well. These are sort of more big picture people. We meet a little less frequently with them, but they try to keep the project on track and help us out with figuring out the direction, whether it's scientific or more bureaucratic, let's say. So let's start out with looking at what it is that the core team does. Well, first of all, of course, we do core packages. We organize these core packages under one umbrella to ensure good development practices. We also have our ecosystem packages, which we as core developers review and admit based on guidelines like test coverage or code quality, these sorts of things. And beyond that, we have the core packages are tested daily against integration testing. So against the main branch of AND data, every core package is tested daily. Automatic issue reports are sent out, and this ensures high quality development of these core packages. And we're actually looking to maybe spread this to the ecosystem as well, another resource that we're going to offer to the community, hopefully. But if it weren't just for these core packages, I don't think that we would have won the award. So, of course, we provide much more than just code to the Python single-cell community. We, of course, have our social media channels. We have Zulip, where everyone here, if you want to, can log on and talk to us, the core developers. I think this is a really great and somewhat underused resource. Like, we try to respond. We have a discourse forum as well for more back and forth style Q&A, where we also really try to reply. And of course, we have GitHub, where you can open issues, make really sort of more formalized feature requests, but also you're welcome to, there's the discussions feature on GitHub, so you can of course engage us there. But then we have within the core team a dedicated social media group, and they manage our Blue Sky, our X, our LinkedIn. And so it's not just code, it's also this social media aspect as well. But before I move on, I just want to highlight our SCverse cookie cutter template, which we also provide to the community. This allows people within the community to develop high quality single cell packages from a good starting point, let's say. This has code formatting, docs building, CI, everything ready to go. And you'll automatically actually get updates from the core cookie cutter template that are made. So you'll be able to stay up to date with the best development practices that SIverse has to offer. But getting back to community, we also have our hackathons, which some of you may have seen. This one is from Heidelberg in 2023. This was my first hackathon. There's also the SIverse website where you can see sort of everything in one place. That's, of course, also maintained by our core team. Everyone sort of mostly on a volunteer basis. Our core community team hosts our bi-weekly community meetings, which are a more informal setting where you, package developers, tool maintainers, methods developers can present your work in a sort of more informal, low pressure setting and get feedback from the community. That happens every 2 weeks. We have our SIverse conference, which many of you may have attended. Again, sort of more tool-oriented conference where we talked about best practices and perhaps new methods, new packages. Anyone who was there, I think, can tell you that it was a really great and sort of low-key opportunity to get to know people within the single-cell community. And lastly, we have our upcoming conference as well in San Francisco this year. Registration is still open, abstract submission is still open, so we encourage you to apply. So all that's to say, we really do put our community first, but that all might have sounded like a lot that we give out, but I do want to highlight that, we also benefit from these. So first of all, you might notice that these packages, which were on the original core package slide, were not on the original sort of SIverse story slide, and that's because they came later. We were able to engage with our community and develop new packages to meet new needs. So for example, PertPy has differential expression wrapped in it, or decoupler, of course, gene set enrichment analysis. So we're also branching out to meet the needs of the community, and then we benefit as SIverse because we're able to share development practices and make development more efficient for the benefit of the community. We also have readers in other languages to encourage interoperability. I really want to highlight the ANDATA-R package here from our community. It has a single-cell experiment and Seurat converters and allows you to use the H5AD file format directly in R. So no more Python R bridging. This is really just a pure R package. We also have sort of these not core packages, but packages that we have some sort of direct involvement with, whether it's assisting in the creation, greenfielding, or in my case, I was a former developer of a test, but these packages really benefit from having a strong, tight-knit community, channels like Zulip, GitHub, where we share information and are able to encourage the development of packages, even those that are not necessarily core. And lastly, the greater scientific Python community benefits because we're able to contribute back, advocate for the needs of our packages, and also benefit the greater scientific community. So perhaps people who don't use single-cell stuff also use Dask, SAR, SciPy, NumPy, these sorts of things. We always try to open bug reports and engage in good development practices. And of course, we think that all this effort we make is reflected in our usership statistics. So we have regularly downloads over 10,000 a month per package, some of them reaching 100, 200,000. So this just gives you a sense of that we feel like our hard work is reflected in these statistics and the feedback that we hear. So just in my last couple minutes, I just want to highlight some of the recent developments, some more technical stuff, some little buzzwords, but you're also welcome to come up to me afterward and talk to me. There's always new features coming out, or maybe we recently came out with something that can meet your need. So one of the recent exciting things over the past year and a half was ANDATA meeting Dask. For those of you who don't know, Dask is a parallel out-of-core framework for analyzing data sets in Python. So if your data set doesn't fit in memory, if you want to parallelize perhaps an algorithm, Dask is a really good choice for this, and we natively support it within ANDATA. We have readers with the data structure itself, so you can bring your own Dask array. And this has been downstreamed, let's say, into SCAMPy and rapid single cell, where a whole bevy of functions have been updated to use Dask from highly variable gene selection to PCA. Some of you may have seen our Tahoe notebook, where we were able to run 100 million cells in a single sort of notebook using Dask. And I assure you that the experience has only gotten better. We're continuing to develop it. It's still an experimental stage, but we have new functionality coming online every release. Recently, we had sc.aggregate.get or .get.aggregate, so you can now do like pseudo bulking using Dask. So if your data set doesn't fit in memory, try out for doing aggregations that you might otherwise use polars or pandas for. Spatial data continues to draw closer to the OME NGF community. So they recently had a RFC accepted into the OME NGF file format, and they continue to engage openly and in good dialogue with the broader imaging community, so not just focused on single cell. scverse again from Gregor has recently done work towards scaling. So this includes GPU and parallel computing for Python users. And lastly, we are aware that the plotting in ScanPy can sometimes be a little tough to use. So we're greenfielding a new plotting effort using HoloViz, which is a sort of backend agnostic plotting library in Python. So not only can you use matplotlib using this, but you'll also be able to use GPU rendering. So for those large UMaps that might take a while to render, this will be much faster. And we'll also get some nice light interactivity and a cleaner API. So these will all be, initially this is its own package, but it will be downstreamed into ScanPy as well. So you'll be able to switch out the backend and take advantage of this new functionality. Before I wrap up, I just want to again highlight our conference in Stanford in 2020 in November. We'll have some great speakers, some workshops. You can submit abstracts. It's a really great way to share tools and know-how. A lot of projects have come out of these events, like I've said. So we really encourage you to apply and hopefully submit an abstract as well. So I just want to say thank you. Here are all the beautiful faces of the people at SCverse. I really want to highlight Fabian Theis of the management community. He's of course, my direct boss. But obviously without him, none of this would be possible. And he's the PI on winning this award. So you can see he really is a big driver of SCverse. And but of course, I want to thank everyone here. Everyone does amazing work. And please get in touch with me, find me. If you have a request, let me know. Write it on GitHub, get on Zulip, ask on Discourse, whatever. Thank you so much.
And so how would you convince them that to switch from Sura to SCverse? What is the main important thing that they should think about?
I would say there's a few things. Like I mentioned, interoperability. So again, we found the NData-R format for encouraging cross-language interaction. But of course, we also are working in other languages as well, like Rust or JavaScript, noticed on the presentation. So the file format itself, so just focusing on NData, goes across the language barrier. So this makes development easy. Another reason is that we scale, I think, a bit better than I've heard in R. Again, I'm not an R user, so I can't say it really. But like I've said, like we're really focusing on Dask for out-of-core analysis. So making sure that if you have big data sets, perhaps we've seen a lot of sort of sample level analysis where you have hundreds of samples from hundreds of patients. You obviously can't load all of this into memory. So having an effective way to interact with the data, not only computationally, but exploration as an exploration is super important. It's something we're focused on. And lastly, the Python ecosystem. So if you want to do deep learning and stuff, we are, we're right at the ground level there. And yeah, and I guess lastly is that unlike Seurat is one project. We're a consortium. You can interact with us on Zulip, on GitHub. We will respond to you. Like I said, we've expanded. We have new core packages. So we're dynamic. We're trying to address the needs of the community beyond just a single package.
Thank you. Thank you.